Hi, friends. Good evening. Welcome back to the channel. And we will be very happy to see you all daily connecting with us and encouraging us, and also trying to take a lot of value add from these sessions. That is the mileage that we also get, right? So we are trying to impart the knowledge that we basically have accrued over the years, and glad to see the continuous support that you people are showing. And keep doing that, keep sharing this so that others also can take the benefit from these sessions. And let's begin the session. Today, I will be taking up the role of the interviewer, and we will be starting with association rules concept. Now, let me put these questions forward one by one, of course. Bernie, I would like you to talk about the applications of this algorithm to start with.
Sure. Hello, everyone, and welcome to the session. Yep, sure, absolutely. So, association rules is one of the data mining unsupervised learning techniques. And association rule has multiple names. Let me share my screen and quickly explain. These are the various names. Association rules is also called as market basket analysis, affinity analysis, relationship mining. And this is a technique which is part of unsupervised learning, machine learning unsupervised learning, or descriptive modeling technique. One of the use cases which I personally was involved while I was working with a different company prior to starting our own company was related to life sciences healthcare. We know that clinical trials are critical for any pharmaceutical company to become profitable and become successful as well. Usually, people say that for a clinical trial to become a success, it takes anywhere between 5 years to 15 years. And because of COVID, and thanks to artificial intelligence and machine learning, people have reduced that duration to 1 year. Okay, and that is the reason why we have seen the COVID vaccine come to light so soon. Of course, it was need of the hour, so a lot of money was getting pumped into this. Having said that, when it comes to association rules, one of the application was to look at what are the various interventions. Interventions means what are the various drugs which have to be provided to the various people. And what is the condition which is being addressed because of that? So interventions and conditions. Condition is disease. Interventions are drugs. Usually when we have any disease, we do not have a single drug. I mean, in most cases, we don't have one drug which will cure your disease. We need to use combination of drugs. So what are the combination of drugs which have a very close association with the disease? Of course, to cure the disease. So in this business problem, tuple that we create is critical. And the tuple that we have created was combination of drugs alongside the disease. This is one project that we have done. And we could figure out what are the combination of drugs which will cure a disease. And this we have done only for successful clinical trials. Because our goal was to increase the success rate of the clinical trials which were being performed. This is one of the application. Alongside that, we have done a project as part of InnoDataTix. It was for one of the beverages company and one of the gold standard companies without naming that company. And here, approximately, $1 million, or rather, let me take one step back. And let me tell you that it was approximately, yep, I think I need not take a step back. Approximately $1 million was spent on purchasing, components and storing these components in inventory. This was for one of the manufacturing plants. And within manufacturing plants, obviously, you'll have machines. And machine components might fail. Components fail. Right? So when the components fail, immediately from the inventory, you'll take the failed component. I mean, not the failed component. You take the component which is working and then replace with the failed component. $1 million was spent on one inventory. I mean, people were using one inventory per location. And in this way, this particular beverage manufacturing company has 17 manufacturing plants. What does that imply? That implies 17 inventories. What does that imply? $17 million being spent just to, procure the components and place it in their inventory. We wanted to establish a relationship between what are the various components which fail frequently. So here, the tuple that we have come up with was, what are the machines which fail frequently and what are the components that fail? So components and machines which fail, because each machine will have thousands of components once again. It is not possible to procure and keep each and every component in the inventory. If that is the case, then a lot of money would be blocked, right? So $17 million for 17 inventories for a few components of a few machines. If you place, that's the cost. If you, obviously you cannot, procure all the components for all the machines and keep it in your inventory. That means your costs would escalate significantly. And people look at what is going to happen if I were to invest $17 million in some other business opportunity. Or if I were to just place this money in the bank, then what is the amount of interest that one would get? So one is the interest that you're losing. Another thing is you could have probably invested this in a better, business opportunity and made a lot of money. So you lost the opportunity, that's opportunity cost, as well as you lost the interest that you would have accrued over a period of time. So we have looked at what are the various components which were failing frequently, plus the machine which was frequently failing. And once we formed a tuple like that, we could figure out critical components. And then we have directed the manufacturing plant, the logistics department, to only procure the critical components which were failing for a specific machine. Not just that, the applications of this are also used in real estate. Once again, when it comes to real estate, you look at what are the various crimes which are committed, various crimes. And we also look at what is the location where these kind of crimes are committed. And how would this help? Yes, this obviously will help real estate agencies to devise better strategies, because a location where there is a very strong association between the crimes and the location, the real estate costs would significantly go down. Okay, and the locations where the crimes are of low magnitude, like someone just doing some kind of a petty theft, etc. There, in those kind of locations, the real estate costs can still be high, or they can be at least average, not below average. But the locations where crimes are very high, there the cost would not go up, right? So investing in these kind of locations do not make sense. So it's not just for the real estate companies, it is also for the home buyers. Okay, these kind of models significantly help. And it also helps in inventory management. So, Amazon has come up with something called as anticipatory buying model. Long back, not now. I think 2014 or even before that. Amazon has come up with anticipatory buying machine learning model, where they have tried to come up with a tuple, and they figured out that these are the bunch of products which would get purchased in a specific location. So when you combine the products plus the location and form a tuple and see what are the products which are getting purchased extensively in a given location, then you can devise a strategy to anticipate what will be the demand for what kind of products in which location, thereby ensure that your inventories are filled with these kind of products. What would happen if you do this? When customers place an order, very easily and within a shorter time, you can deliver the products to the customers. So in this way, there are umpteen number of other use cases or applications of association rules. But the point that I'm trying to drive here is that defining tuple is going to decide on how effectively you would be solving the business problem of the client. So, yep. So these are a few of the applications here.
Thank you so much, Bernie. That's a very detailed answer. A lot of students, right, who are learning data science, I'm pretty sure they were eagerly waiting for a retail example. As soon as we talk about association rules, the immediate thing that flashes in our minds is retail sector. So there you go, friends. As Bernie explained, association rules is not only confined to retail domain. It is basically applied in other domains also. Like Bernie explained, the manufacturing sector example where inventory management was done. Retail example was done. Life sciences, healthcare, right? So on and so forth. Aviation can be talked about, right? Various other things. Now, let me try and look at some other questions. Now, what can we basically do to measure these combinations, the tuples that we are talking about? We call them as rules. If the students are getting confused with the terminologies, then tuple is nothing but one rule, friends, in association rules, right? So we call them as rules. So how do we generate these rules, Bharani? Maybe you want to throw some light on that?
Yeah, absolutely, Sharat. So We have a few algorithms, and one algorithm which is very extensively used in the space of association rules is a priori algorithm. And within a priori algorithm, you have to provide certain inputs, such as support and confidence, right? And support and confidence are also called as performance measures. You obviously do not want to include those items or products which are purchased, minuscule in a minuscule manner. If the purchases are very limited, you need not even analyze that. Doesn't make sense, because association rules usually looks at majority. Okay, and we want to target majority of the customers, or majority is what we want to target. And here we have support, which is one of the measures, which ranges from 0 to 1. The higher the value, better it is. And within support, we also have something called as antecedent and consequent. For example, if you have this, and this drug, then this condition or this disease will be cured. But what is the confidence, or what is the support? In how many clinical trials this, and this drug was used to cure this disease? So support answers these kind of things to help us understand whether these combination of probably drugs to cure this disease, or these combination of products being purchased in this location, what is and how many people are actually purchasing those products, so on and so forth. The more number of people, the more the number of purchasers, better is your association. Alongside that, we also have confidence. Confidence also ranges from 0 to 1, but confidence does not just look at how many people are purchasing the products, or how many drugs, or in how many clinical trials these combination of drugs are being used, or in which location maximum crimes are being conducted, or these kind of crimes are being conducted in which location. It doesn't just look at that. It also looks at the probability of the association among your tuple items. This is called as a tuple, and among the tuple items, what is the probability that these are very closely associated with one another? But then confidence assumes that there is some kind of independence between all these. All these are independent events. What if they are dependent, right? So if you want to answer those kind of questions, you proceed further with something called as lift ratio. And lift ratio value, if it is greater than 1, that implies that there's a strong association in rules. This lift ratio looks into confidence and something called as benchmark confidence. So it looks at what if two items, or what if the various tuple items are dependent on one another, and what if these tuple items are independent of one another. Given these two scenarios, we come up with lift ratio, and it ranges from 0 to infinity. Obviously, greater than 1 means your numerator is higher. That means the items are more dependent. I think there was a small mistake which I have made while I was explaining about confidence. Confidence assumes that items are dependent, and lift ratio looks at how dependent are they in comparison to how independent they are. Okay, and if the lift ratio value is greater than 1, that means numerator is higher. That means items within the tuple are more dependent. In that way, we have something called as leverage. We have something called as conviction. All of these are the different performance measures using which you determine whether your association rules are strong or weak. Yeah, thank you, Sharad.
Great. Thank you, Bernie, once again for a very detailed answer. Yeah, definitely. The confidence you have used the independence as the keyword. I was about to capture that, but yes, you have corrected that. So, friends, the calculations that we basically talk about, right, is to generate the rules is based on probability formula only. So, majority of the data mining concepts that we basically use in developing machine learning models, they use basic mathematical concepts, and probability is one of the heavily used concept. So support, confidence, and lift ratio, they are depending on the entire probability calculations. Now, let me also ask a question more of a practical application perspective. So can you throw some light on the package that is used in Python for developing this or implementing this association rules, and what kind of hyperparameters we use? Continuing on that point, there is one specific question that I as a trainer always get. That is, we need to have some kind of a benchmark upfront defined for support or for that confidence ratios, that confidence measures that we are calculating. For lift ratio, you have anyways mentioned on why we have to use lift with a threshold of 1. But can you also explain what should be the value for support and confidence, and how do we define the preliminary or first threshold values for these parameters?
Yeah, sure. So the Python library, which is used in performing association rules, is ML extend. In fact, we can use other libraries also, which exist, but this is most widely used. And in order to decide the support value or the confidence value, one needs to possess domain knowledge. For example, say there is a retail store in remotest of the place, and where probably only 10 to 50 customers visit on a daily basis. So you obviously cannot have a very high support value, because the number of customers who are going to purchase your products would be less, given that the number of footfalls itself is going to be low. Okay, and hence one has to have the domain knowledge on what kind of items people purchase in that location and how many items people purchase in a specific location. And also we need to understand what kind of audience or what kind of segment exists over there. For example, if it's a very posh location, obviously people would be from the higher income group, the wealthy, people. In those kind of scenarios, the support and confidence values vary. And the locations where you have middle income group, if you are doing analysis for a retail store over there, obviously the things would be different. If you're choosing support and confidence for a startup, obviously the number of purchases or the number of items in the tuple would be less in comparison to a well-established company. So based on that, you will have to change support and confidence. It would not be an easy task to choose these. You need to sit with the business owners. You need to sit with the store owners. You need to, sit with the people working in those stores, etc., and then try to get more understanding. That's point number one. And point number two is, okay. And point number two is experiment, right? One has to experiment if they are in doubt. Choose different support values, choose different confidence values, keep experimenting, and then decide what combination of these values give you good result. Hence, this one term that I would be frequently using would be experiment when in doubt. Usually this is what you do, because the domain knowledge might not be sufficient in choosing the support value, but it will give you some ballpark indication. But otherwise, this is going to be a golden rule: experiment. And there are a bunch of hyperparameters which exist. One is the minimum support. The support value, it ranges from 0 to 1, and it's a float value, meaning you can also, provide decimal values here. And then you also have maximum length. Do you want the rules to go until 100, all 100 items together, or do you want to restrict that? Yeah. And yep, so on and so forth. So once again, there are a bunch of hyperparameters which exist. Is it humanly possible to remember everything? Not really. But then, can you, at least remember a few important things? Absolutely. And here we go. These two, I would say, are important when you use a priori algorithm, but there is also another function called as association rules. If you are using that, then metric is something that will help you, evaluate the different rules in a proper manner. Here, the default value is confidence. However, you can also use support, lift, leverage, conviction, etc. But when you use this, all these different metrics would automatically get generated. And I also see that there are certain questions. Oh, 1 second. Are there any specific questions in LinkedIn? Are there any specific questions in LinkedIn what you shared? I didn't quite get that question, Govinda. Sharad, did you understand that question?
Not really. Probably a participant here might want to ask about specific questions that we are conducting or discussing here. Are there any documentations or something like which is readily available? So for you, I would recommend you navigate to the mind maps on our website. We are updating the questions also onto the mind map. So today's discussions will be also get updated there, and you can refer to that as your document.
Yep, absolutely. And also there is in learning resources, we have the cheat sheets, and we are updating those in learning resources. Under cheat sheets, when you click on download, of course, you need to provide your details, and then you'd be in a position to download that. And also, I see that there's a question on what are these? Confidence, support, lift, what are these? Is a question from Karthik. Karthik, these are called as performance measures. Like when you build your machine learning algorithm predictive model, you look at accuracy to determine how good your model is, right? In that way, for a priori algorithm, we have performance measures. Yeah, over to you, Sharad.
Yeah, thank you. Thank you so much, Bernie. Yeah, so friends, there are a lot of content that is being created and is being made available to you all. Please do visit our YouTube channel, subscribe to the channel, learn more, ensure you prepare yourself to face the interviews with confidence, and you should be able to crack the interviews in the first attempt, right? So that is the objective of these sessions, and kindly do use these sessions. And for required material, as we have just shown, go to the website 360 Digit MG. Learning resource is one of the tab that you might want to explore. We also have mind map, right? So use these resources for your preparation. Always ensure that you focus more on the application part when you are speaking about any data mining project. Domain knowledge is going to give you the confidence and boost when you answer the questions. With that, let us wrap up this particular session for the day. And we will again connect back in our next session, which will be on Monday. So Monday to Friday, we will keep discussing about new algorithms, new type of questions, right? So keep watch out. Thank you so much.
And this Sunday, Sharath, you're conducting the deployment session. Maybe you can just briefly explain about that.
Yes. Thank you for reminding me that. So connect with us on Sunday, friends. We will be discussing yet another web framework tool, which is Python Django, which is called as a full stack web framework tool. And using that, we will be creating the UI, which is required for machine learning models. And we will be taking that entire model and the UI and deploy that so that the end user can actually use the functionality of the model that we are developing. So not just developing the code, but also ensuring that the end user can start readily use the solution. That would be something that we will be discussing on Sunday. Please do connect with us.
Yep. Thank you all
Thank
so
you
much,
so much.
friends. Happy learning. Bye.
Thank you all.